from
Like on
beginning.
Twitter sources,
Skype for social.
he's like an officially like credible.
Alright, so welcome everybody. Today we're here to talk about the linker, which simply put is the thing that takes the stuff checked into P4 and makes the stuff the game can read. So
That's the title.
the rest of this presentation is going to be more complicated than that, so let's just kind of get the gears spinning. Oh man.
Did you turn it on?
Yeah, totally turned on.
Try turning it on.
So about me, any ideas for how to get this guy working? Just a little about me. I'm Stephen Crow. I'm a senior software engineer. You can also call me Steve. I've been here for 9 years.
You get to plug in the dongle for it to work.
Yeah. I've been here for 9 years. When I first started, I was on UI. Soon after, I moved to work on texture streaming for a project that didn't end up shipping, but that tech got ported over to Black Ops 1. For Black Ops 2, I worked mostly on engine-related tasks. A lot of them touch the linker, so that's kind of why I'm giving this presentation. And then for Black Ops 3, I moved to the UI team to lead that effort. But you already all know that because you saw my flyer, right? Thanks, Stephen, for that. All right, so a brief overview of this talk. Briefly, I'll talk about the expected takeaway, and then I'll talk about the linker in 3 parts. Very briefly, why we have a linker. Less briefly, what does the linker do? And somewhere in the middle, how does the linker do those things? Those numbers changed and I didn't update the slide counts, so don't count, but just as a general idea. So expected takeaway for this presentation. By the end of this presentation, you should know how to diagnose and fix some local fast file problems. You'll see a lot of code broken emails. I built the game and I get this assert, how do I fix it? Find out which game files an asset is loaded in. So if you edited a text file and you don't want to link every fast file in the game, you can find out which one fast file you need to relink. You'll understand a little bit about stub assets and asset dependencies, which I'll get into later, and you'll learn how to create or modify an asset type, which I'll also define later. But first off, why do we have a linker? As I kind of defined the linker's job before, the linker's job is to build many source assets into the few files the game reads. So as you notice, you sync P4, you download about a million files the first time and a few less on later times, but in the end the game only reads, I'm going to say like 20, 30 files, unless you're like running through the entire game, in which case it reads a few hundred. Oh, also I should note that I'm not going to talk about audio. If you want to know about audio, you should ask Blair or Stephen McCall. I don't really know a lot of that, how the audio stuff works, but most of it does not work the way the rest of the linker works. So, caveat, I'm not talking about audio. So first off, why have a linker? Why not just read out of loose files like Radiant does? First point is reading loose files is slow. Seeking on a disk to where that loose file is, and then seeking on the disk to where another loose file is, especially back in the days of DVDs, was very slow, and even today is still slow. We also do some asset conversion in the linker, so we're converting from like a TIFF or PNG into the internal format that the graphics hardware uses. We don't want to do that on the fly because it would take half an hour to load level instead of 30 seconds. The linker lets us have the game just load a few files and have them in the right format on each platform. So sometimes we'll convert some bit order differently depending on whether it's mostly PlayStation 2 or Xbox 360, but less important these days. But like I say here, there were bigger problems on older hardware, but so we could potentially, or new games could potentially get away with reading loose files, but loose files are still slower. So so use the linker. So part 2, let's talk about what the linker does, what it takes as input, what it spits out as output. This is the vastly oversimplified version of what the linker does. It takes a bunch of different types of loose files that you might have seen, runs it through the linker, and produces something .ff. xmodelbin, xanabin, d3dbsb. I'm just trying to throw enough extensions up there that you recognize some of them. It's not important to remember all of those, but it takes those loose files and converts them into something. A little bit more complicated. those source files, I've moved over to this column here, often come from different source files, like the D3DBSP is originally a .map file, which is what Radeon outputs, and then there's a tool called Cod2Map that converts that to a BSP. The artists make a PSD and save it out as a PNG. So when I say source files, it's not quite a source file. It's sort of an intermediate game file. And then another point from this slide is that Linker doesn't just output a .ff, it also outputs some other things, which we'll talk about later. So the first thing we'll talk about is one of the other things it puts out. Actually, no, we'll talk about that soon. But anyway, we'll talk about, if you look in the game share zone source directory, and when I mentioned the path starting with PC or share, those are in //g8 main game. So G8 main game share zone source. You'll see 3 different extensions. You'll see .zone, .class, and .zpkg. You'll probably ignore the .class, but I'm going to tell you about it anyway. So first off, the .zone file. You'll see for every fast file that the game has, you'll see a .zone that has the same name for it. So core-pre-gfx.ff, you'll see core-pre-gfx.zone. That's the main file that defines what's in that fast file, so that the linker knows how to build it. There are also a bunch of zpkg files. The .zone file can include as many of those as it wants. The .zpkgs can include as many other ones as they want. So that's kind of what I'm showing with this picture over here. But you cannot tell the linker to build a .zpkg file, not because it wouldn't know how to do it, because those are basically the same file format as .zone, but just so that as a team we can organize things better. So you can look in this zone source file, sort by .zone, or sort by extension, and look at all the .zones to see what fast files we can build. So tools like Rex look in the zone source file, find all the .zones, and then give you a list of fast files you can link from that. So that's very easy. The .class fast file, or the .class file, exists for a few different reasons. Mainly, there's a lot of functionality that we need to say every MP level, every CP level, or the common fast files like MP common, CP common, and ZM common. We want them all to share some properties. Some of that has to do with what files should be ignored in this fast file, which I'm going to talk about on the next slide. Some of that has to do with what kind of files should be output by this. But basically it just lets us define behaviors for groups of fast files. And it also lets us define those filters in Rex. You'll see core, CP, MP, ZM. That's determined by the class file. Okay, and the zones and Z packages, the meat of what's in those files is these lines here, asset type, comma, asset name. So asset type, say you want to include an image in your Z package that's included in a zone, you would say image, comma, and then the name of the image as you see it in Ape.
I got a question.
Sure.
Where are those asset types defined? Like images, like what are they?
In 2 different places. One of those is in the db.h files. There's a asset list that I could point you to, but I don't know off the top of my head. And then another place you'll find those is in default.class for any script bundle asset types, which I'll also get into. But yeah, I'll follow up on where the list of all the asset types is. But if you search code for asset underscore type underscore in caps, you'll see an enum with all of those. And you'll also see an array of strings that corresponds to that. So it'll be like quote image quote and then / asset underscore type underscore image.
Okay.
So you use the word image, that was what's in quotes, to define an asset type image.
Don't worry, you gotta do this with that for your assignment later.
I made that part optional, but yeah. Well, you'll add a script on the last end. Okay, so I kind of touched on this a little bit, but one of the purposes of the class files is to define which other fast files a fast file ignores. But I have to define what an ignore is. We have a lot of common fast files that are loaded all the time, and some like MP common, ZM common, MP patch, ZM patch, same for CP. They're loaded depending on which mode you're in. Just real briefly, the purpose of having MP common and ZM common and all those fast files is because it's full of assets that are common to every MP level, but aren't used in other modes like CP. So if you go from one MP level back to the front end, back to another MP level, we keep MP common loaded the entire time, so you don't have to reload all those assets. You don't have to pay that that cost of load time and mostly load time. So you'll notice when you go into a match for the first time, maybe it'll take 25 seconds. And then when you go into the next match, maybe it'll take 12 seconds. Maybe that's a little different, but that's because MP common fast files are helping you out. Also, as a bonus side note, those MP common, ZM common, those are loaded in the front end. So as soon as you select multiplayer, we start loading that fast file. So unless you jump right to a match right away, if you like play around with your creative class for a minute, then you'll get that speed boost even for the first map that loads. Okay, so this is just kind of a little snake line that shows how we ignore things linked in fast files, or how fast files are linked from core PGFX to core patch to core GFX, and then they're loaded in this order too. Like if you look in Rex, this will be, if you click the little plus button to see all the fast files that link, this is the first one that's going to load, and then it's going to go in this order, and this is the last one that's going to load. But that's also the way we load them in game, not just the way we link them in Rex. So everything that's loaded in core PGFX, everything linked into that, if we come across the same asset in core patch, we don't need to include it in core patch. If we come across an asset if we come across an asset in core common that was in any of these files, then we don't need to include it in core common. So the way we would do that is we would put a line in core common.zone, or actually probably the class file, that says ignore comma core UI, ignore comma core plus GFX, ignore comma core GFX. So right, so that when we link MP common, which is loaded after core GFX, can you guys kind of figure out what is gonna look like behind this brown box? Like, if we have an asset that's loaded in both core GFX and MP common, is it gonna be like green/orange? Is it gonna be green? Is it gonna be orange? Anybody want to guess green/orange?
I'll guess orange.
Any greens? Any oranges? All right, yeah, it's orange. So yeah, and then a little bit more complicated. We loaded core GFX, and then we loaded MP common, and then MP sector. I won't quiz you on this one, but again, this overlap area is gonna only be in MP common. This overlap and this overlap only in core GFX. So that's the goal of how ignores work. We'll talk a little bit about how it's done.
So they wouldn't be loaded again, like a newer version will not be loaded, right?
Well, if you need a newer version to be loaded, it can get loaded, but the default behavior would be no.
Oh, okay. So it'll basically, if it's a duplicate asset, you can just ignore it.
Yes.
Okay.
But we have exceptions like the fast file of the day needs to be
Right.
able to overwrite any asset, so it doesn't ignore anything.
Right.
But that's sort of outside of the scope of the slide. So the way the linker handles this, like I said, is ignore comma and the zone name. And then when you're linking core PGFX, or I think the example I used here was core GFX, while the linker is building that fast file, it also creates a list of all its assets and saves it to PC zone source all asset lists, name the fast file.csv. And here when I say PC, I mean PC Orbis or Durango. I just picked PC because it's the shortest. So it makes things look a little less complicated. And then when you ignore core PGFX in your fast file that's loaded later, the linker opens this CSV, gets that list of files, and then creates a stub version of anything in that list. So basically, as an engineer, you can think of a stub version of an asset as just a pointer to that original asset. So an asset kind of defines a bunch of values, like maybe it has some numerical values or some string values. and then it also points to other assets. Actually, string values are assets, so those don't really count as fields. But basically, you'll have sub assets for the strings and for like other assets included by your larger asset. But then it'll repeat things like numerical values. Like say a weapon has a firing rate. When you have your weapon asset ignore all the models and all the other materials that are part of that weapon, then you just create pointers to those materials and models, but you can overwrite the numerical values, like make the gun shoot faster or slower, or reload slower, reload faster, that kind of thing. So you'll have stub pointers to the larger pieces of it, and then your asset won't cost as much you won't have as much duplicated. You'll have like 200 bytes instead of 40 megabytes. Okay. So I'm going to take an example asset of an animation. And this is an example asset that includes other assets. So if you look at O_Spidermind deploy, that includes this GDT asset, which is define an ape, which I think everybody has some familiarity with. So the main part of an XAnim asset is to point to an XAnim_bin file. That's a binary file that gets exported from the animator's animation tool. So we add that binary data into the fast file. It also, the GDT entry also includes an XModel pointer, which isn't really included as part of the XAnim because that's a separate asset, but we parse that while we're deciding what to do with the binary animation data. So that's going to influence what this data looks like at runtime, but we're not going to load that data directly into the fast file. And then it sets a bunch of fields here, which float values, bool values, enum values, that kind of thing. They're pretty straightforward. And then lastly, under this notification that a new driver is ready, it says it loads this asset. Here we go. So there's an FX asset down here. FX is another asset type. This anim uses this effect, so this effect is loaded into the fast file whenever this animation is loaded. So for example, FX Spedulite I think is included in a core common fast file, and the Spidermind deploy would be in a later fast file. So by the time it gets to here, it would realize it doesn't need to put that into the fast file because it's been ignored. But yeah, that's the main point of this slide, is just to talk about how the main asset, the XAnim, pulls in two other assets, sets a bunch of fields, and is more complicated than just a one-to-one, like here's an XAnim asset, it came from an XAnim bin, end of story. There's other stuff that goes into the XAnim that it pulls in, and the linker does that automatically when it sees the FX asset. Here. This slide is just to say it can get a lot more complicated than just an FX. This is a vehicle, an MP. It pulls in a bunch of models, script bundles, effects, materials. Those models pull in mesh assets. So a real dependency tree often looks more like this. There's sub-assets, and those assets have sub-assets. So by pulling in one asset, you could be pulling in a couple thousand assets. I think weapon assets are around like 1,000 or 2,000 assets that get pulled in just because you set a weapon. This screenshot comes from MemoryPort, which is a very useful tool for figuring out what's in a fast file. So you can open MemoryPort. This is an NP common, so I double-clicked NP common, and then I hit Control F to do find, and I searched for this spawner VO3 AI tank NP player, and that's how I see in nice pictorial form what that asset pulls in. If you don't like that version of it, or you just want to be able to search in all the files rather than just an NP common, you can find this information in PC's own source all asset info npcommon.deps and npcommon.csv. So I'll often do like a Control-Shift-F in Visual Studio, or my favorite text editor, put this path up to the asset info, as my location, and then star.csv is the extension, and then put the asset name, and that'll tell me that, okay, this asset is loaded in NP Common, and its dependency chain is like, it'll be part of that asset info CSV as a, I forget what that thing's called. The thing on the backslash, the bar, vertical bar. Vertical
Pipe.
bar separated list.
Pipe.
What?
It's called the pipe.
Pipe, okay. Pipe separated list of assets that end up pulling in the one I was looking for. So those are both really useful tools, MemReport and also the asset info folder. And then the last point I want to make, this is an example of a vehicle that pulls in a lot of sub-assets, but really the ultimate asset to think of as bringing in millions of other assets, probably not millions, but pretty close, is Radiant. So while you're working in Radiant, if you drop a model into Radiant, it'll pull that in as a dependent asset. That model will pull in all the materials, strings, attached models, anything dependent on that, etc. So if you drop that model into Radiant, then you don't need to say X model, comma, my new model in a zone or Z package file. You just put the Radiant BSB name in, and it pulls that in for you.
So a dependency is basically if an asset comes from a dependency, then that dependency file is supposed to tell you where it came from, right?
Right.
Right. So that's why we have a dependency file and not just like a flat asset list.
Right. I mean, are you talking about the .deps and the .csv?
Yeah.
The .deps is, I believe that's actually used just by something I'm going to talk about on a later slide. And the .csv and asset info is just kind of informative and feeds into MemReport. So those are just for us. If you deleted your deps and CSVs and linked the game, you wouldn't get any errors. I talked about the asset list folder a little while ago. If you delete that, then you'll get a bunch of errors about how I don't know how to ignore core pre-GFX because I can't find the asset list core pre-GFX. Yeah. Okay, so we've talked a little bit about how zones and Z packages define what's in a fast file, and they pull independent assets and all that. There's a little bit more that goes on when you run linkerpc.exe than just linking that one fast file. So the first thing it does is it spawns more linkers. So if you link core all, you'll notice it says linking this, linking this, linking this. Every time it says the word linking ... that's a new linker process. So if you were to look at, Control-Shift Escape and see Task Manager, you'd see a whole bunch of, or you'd see probably two at a time. The main core all one, and then the sub fast file that's linking. So the first thing it does is anything listed with greater than prelink in the .zone or any included .z package, but hopefully we only do this in .zone files because otherwise it would be confusing. It links the prelinks. So like I said, core all links core pre-GFX, core GFX, and 5 other fast files. Core frontend has a line that says prelink core frontend patch. So that's why you'll see in Rex it says core frontend, and if you click plus it'll say core frontend patch. It's the prelink that made that show up in Rex, and that's the prelink that makes that actually happen. So the first thing it does is it does the prelinks. They're called prelinks because they happen first. The third thing it does is loads. So I'll ignore that add load fast files for each of those for now. I'll get back to it. Second thing it does after all the prelinks is it links the fast file that you said you wanted. So it might try to link core all.zone, but that's really just that just exists to organize all our fast files. So there's nothing in that one except a bunch of prelink lines. But for example, core frontend, it'll link core frontend as the second step. And then third, it links a load fast file per language you have checked, which is usually just English. If you want to link more languages, you can go to Tools, Options, Advanced, and check the Show All Languages button, and then restart Rex, and you'll see something like 12 or 14 language options. But generally, it's going to link the fast file you selected and en underscore the fast file you selected. So core frontend and en core frontend. The way it links localized fast files is auto-generated, runs pretty automatically. for example, if you're linking core UI.fast file, when core UI.zone links, in addition to the other things it's generating, it generates a file underscore zone source / loc / core UI.zone. And it puts into that, while it's processing all your assets, it puts into that loc core UI.zone every asset that it found in an English subfolder or tagged as square bracket English in a GBT. So if you look in Ape and you type square bracket English and square bracket, you will see a bunch of things that mostly artists have defined as specific to a particular language. So by tagging something as English, well, we make sure that asset loads in the per language fast files. So we end up with no localized assets in core frontend.ff. They all end up in en core frontend, which lets us, when we're building our game with 12 different languages, it lets us do that very quickly, instead of linking 12 different versions of the big fast files. So Keithan?
Those are not just like strings, right? That could be like an image,
Yeah.
only be in a certain country or something like that, right?
Right. So strings are the most common, or strings and audio are the most common localized assets. Strings get moved into the looks folder because they're all under an English subfolder of share raw English localized strings. And then, so in the UI we'll have things like double XP, and we have an icon, and the artist wanted full control over that in all languages. So it's XP in English, but then it's like PX in French, and it's something else in another language. So we have localized images also. It's mostly images, audio, and strings. There might be exceptions. Like if we needed to make a particular image less bloody in German, or not have a Nazi symbol on the shoulder of a Nazi zombie, then we would make that a localized image.
For the mannequins in Newtown, if we have to make them all male or something like that?
Yeah. Was that for Arabic? I don't
For
know.
Arabic, yeah.
Yeah.
Do we still do the green blood for German?
I'm not sure.
I think we used to though.
That could be a localized effects, for example, though.
Right, yeah.
Blood splatters on the ground.
Yeah.
And then, like, if we ever have the word prophet in English, we can't have that in the English Arabic SKU, so we have a separate language called English Arabic where we change it to messenger. Something like that. Yeah. Okay, and look back to the point one. While you're linking prelinks, you also do loc fast files for each of those. I think this is the last kind of file that I'm going to talk about that the linker outputs. Xpacks. These are I definitely have to tell you about these because this is what I worked on for Black Ops 1 and then renamed for Black Ops 2. So Xpacks are files that contain streamed assets. So while they take all of the memory in a fast file and allocate memory for it, static memory for it at runtime, we don't want to do that with things like images and model data that we just have way too much of. So we might have, at any given time, we might have like 10 times the images and meshes as what would have actually fit in memory. So we have streaming tech that pulls in just the meshes and images that it finds out are closest to you in proximity in the 3D world, and then we also do it for UI, so we'll force an image in that we're going to need for, say, level up notification that most of the time you run the game, you're not going to see the you leveled up your AR standard and got this new camo icon, so we stream that icon too, instead of loading it into static memory. So the place where we put all those streamed assets, mostly meshes and image data, are .xpack files, which we also generate one per fast file that links. We've got our CoreGFX.ff, which comes from CoreGFX.zone, and also creates a CoreGFX CSV in the loc folder and the asset info folder, and then also generates CoreGFX.xpack.
Is the
Yeah.
format of like the data in XPack significantly different from the way it's formatted in .ff?
Yes.
Okay.
It's much more straightforward. Xpacks are generally like a header that says, here's this piece of data, here's its offset in this file, here's its size in this file, and then we dump the data where the header says it is. Whereas fast files are much more complicated. So an XPack is like an index into a binary piece of data that you look up by hash, whereas a fast file is, I'm just gonna say much more complicated and move on. So in addition to the fast file outputting XPacks, build management runs a tool called xpacktool.exe that combines and further compresses these assets. If you check this checkbox in Rex, it says optimize XPacks more. That'll also happen for you locally, but I don't recommend you do that because it'll take a really long time to build and won't save you that much time in the long run. I should probably just remove that option. But actually, if you're building a fetcher build, you could check that. That would be worthwhile use of that checkbox. And if you were to run it on your overnight build, that would potentially help a little bit with file sizes and runtime loads in the future. But just stick with the recommendation, don't do it, that's fine. If you're curious about what's in an XPack, like I just kind of explained, it's got a header and then pointers via hash to a bunch of different data locations. You can run this tool in tools XPack called xpackdump.exe and then put the path to the XPack file that you're curious about, and it'll give you a CSV. So you could output that to a .csv file, open it in Excel, filter it, add things, mess around with it that way. It can be kind of interesting. It might not be totally practical, but if you're curious, you can play with that. Yeah.
Does the .csv file contains assets in both stream and in fastfile, right?
No, it just looks at the XPack. Wait, which CSV?
The .csv.
Oh, the one at the fast file
asset.
outputs. So yes, if you look in memory port, oh yeah, there we go. We actually have a resident size column and then a stream size column.
Okay.
So this is what's loaded into static resident memory, and this is what's loaded in the XPack. So this asset here, I'm just going to point at a random one, says 0.926 megabytes. So that's the maximum amount of memory it can take up if you stream all levels of that collision tree, XML mesh. It will take 0.926 megabytes. Much more often, it will take maybe 100th of that, because you're not close enough to this asset to need to load the whole megabyte version. Okay. So I just want to talk real briefly about the share asset convert folder. When we're linking assets, you guys who are new will definitely remember how long it took to link fast files the first time you were in the game. That's because your asset convert was not yet populated. So every time we build an asset, if it's an image or every time we build a asset that's more complicated than like a string, which isn't worth putting in any kind of cache, we first check the local cache, which is your game share asset convert folder, to see if you have that asset. If you don't have it there, we check the remote cache, which is a shared network location, to see if the asset's there. If it's in your local cache, you just pull that binary data. If it's in the remote cache, you download that and then use it. And if it's not in either of those, then it will go through the slower process of actually building that asset. Once you've built the asset, if you didn't find it in the remote cache, there's also a linker option to let you upload that asset to the remote cache. I think right now, mostly it's just build management running with that flag, and possibly some people who are about to make a big linker change and want to save people the long asset convert times.
I thought that was on by default.
We might turn it on by default for everybody. I think that decision is
I
still
don't
being
think
made.
so, because I think there's still been some times where people see these massive image uploads and everyone's just like.
Yeah, but like, I mean, the uploading to the remote cache was on by default in the past projects, wasn't it?
It may have been on by default for some periods of time, but it kind of introduces risk.
Right.
If I'm messing around with an asset type locally and I upload some broken asset, then it's going to be broken for everybody who hasn't built it yet, so that's bad. So it's kind of dangerous, but also powerful. If you want to know more about the nitty gritty of how we use our local cache, you can look up content addressable storage on Wikipedia. We have an interesting data signature.db that's kind of that takes hashes of the source data and looks for files in these folders under asset convert, and speeds up the times for that instead of doing a file existence check every time you want to see if you have a asset. So that's if you're interested. So I want to talk about dependency checking. So you might notice when you link a fast file, it says linking core pre-GFX unchanged, and then it says done after like half a second. It used to be that we would link every fast file that you requested to link, but new in T7, which I know isn't new to a lot of people, we added dependency checking, so you can just leave every fast file checked and link all your core fast files in a couple of seconds, and then and the reason that it only takes a couple seconds is because while the linker is building up its list of assets, it's checking to see if any of them have changed since the last time you linked them. That's actually where that .deps file that we talked about earlier, that Samit was asking about, comes into play. The .deps file lists the GDT that your asset was defined in, the asset type itself to see if that changed. Let's see what else. Any source like PNG, TIFF, that kind of source file, and any asset that it includes. So like I showed you that XAnon version, it would list that X model, the EFX, and the GDT it's in as its dependencies. And then when any of those files change, it'll relink, it'll decide that it needs to relink that fast file. So dependency checking is just if nothing has changed, then we skip building the fast file. So you can leave your common fast files checked whenever you link, and it'll only cost a few seconds. There's a no dependencies checkbox in Rex that you can check if you're having problems, but you probably don't need to do it. It's what everybody tells everybody to do the first time they're having problems, because it solves issues like somebody built a fast file, canceled the process partway through, and ended up with corrupt data. It'll force it to relink. But generally, you don't need to do that. Yes?
How are we checking if the asset has changed, just to save a timestamp? Look at the modified time on the file.
It might be the timestamp or the hash. I think it's the timestamp though. But look in the .deps file and see what that line contains, whether it's a timestamp or a hash. Because the hash would be expensive.
Right.
Like you'd have to read the entire file,
Yeah, it would take
hash it,
longer
and it would
than
take too
like
long.
half a second.
So I want to say it's the timestamp.
I think we first check the timestamp, and then if the timestamp fails, then we check the hash.
Oh, I see. So if you touch a file, no, I think because if you touch a file that didn't change, it still triggers a relink. But I'm not sure. You can try that.
Is it like the last modified timestamp? Or the last touch?
Yeah, last
I think you used the last
touch.
modified, but then I thought it would do a secondary
Right,
hash
yeah,
check
yeah.
on the file.
Okay.
But
Yeah.
I could be wrong about it. It definitely checks the timestamp at the very
Okay,
least.
there we go. At least it checks the timestamp is the answer to that question. Even more fancy and new is incremental linking. So whereas in T7, if you caught an asset that had changed, you'd have to relink the whole fast file. In T8, Dan Olson is developing a new feature where you'll only have to relink parts of the fast file. So you'll read in the data that's in the existing fast file, modify just the parts that changed, and then save it out. If you know what incremental linking is in the code world, it ends up kind of memory inefficient, so we can't end up doing it for like a shift game executable or anything. But this incremental linking is going to be fancy in that it will create an identical fast file to the one that it would have created if it built it from scratch. So this is just going to be a nice improvement to the way we link fast files. You can add dash incremental in your T8 options right now, but there might be bugs. Dan Olson's working on it, but he's moving off the other test right now, so if there are bugs, they're probably not going to get fixed for a while either.
This is completely different than the dependencies though, right? Or is it just a?
It's related.
Because how is this going to work with the dependency check?
Well, so right now the dependency check fails and you relink the whole fast file.
Oh, right, so this is
from
going
start to
to
finish.
check.
But this is going to say, Well, the
Only
dependency
those
check
assets,
failed
right.
for these 5 assets, so let's rebuild them.
This is
Take
pretty
the
fancy.
other 300, yeah, it's pretty fancy. That was what I was trying to get across here. Okay, also I want to mention, since I have this nice screenshot of your linked fast files, I recommend adding debug depths as an option for everybody. It tells you which assets changed that triggered the relink of that fast file. So every time you link a fast file, it'll either say unchanged or it'll tell you the first asset that changed that triggered that relink. So while you're linking all your fast files, you'll see like core common is going to say asset changed underscore objectives.gsc. And then you'll be like, yay, it caught my underscore objectives GSC changed. And also, oh look, that fast file is in core common.ff. So you learn a little bit about where the asset is, and you just verify that the linker caught that change that you made. So it's just a good way to learn stuff and figure out what's going on, why the linkers are relinking your fast files. No, we already talked about this, didn't we? I think I just copy pasted this slide. Yeah, okay, that's that slide. Okay, don't worry about that.
I have a question.
Yes.
For the cache, like,
Yeah.
when we link like a specific asset, does it have like, a specific extension in the cache before we pull it in the first file?
Well, the files under these folders are asset name underscore and then a hash of all the data from that fast file. I don't know if they have an extension, but I think they're probably just extensionless.
Okay.
But the idea is just that you'll only find the asset if it's from the same source data as the last time you filled it. Does that answer your question? Okay. Alright, so we're done with part 2, what the linker does, kind of as a general overview. This is the last section. It's a little shorter than the previous section. We're going to look at some linker code and how to create an asset. I apologize for all the text on the slide. I was supposed to turn it into pictures, but I ran out of time. We'll talk real quick about how assets are processed. There are really 2 different types of assets, even though there are 3 bullet points on the slide. There are simple script bundle assets that are used by scripts only, or at least primarily. I want to say only. An example would be collectible. If you look in default.class, which is in the shared zone source folder, you will see a line that says greater than script bundle comma collectible, and that is the entire way that we define the collectible asset type. So whereas there's an asset underscore type underscore image in code, there's no asset type collectible. This is just a data only asset type that we call script bundles, that we don't call code bundles, much as Sunit wants me to. So if you want to add a new script bundle asset type, are you guys familiar with code data dependencies? I can take a step back. I don't see a lot of nods, so I'm going to talk about it. When you check in a code change, if you have code files and script files like Lua, GSC, CSC in the same check-in, you're going to break a bunch of things, most likely. The reason is that not everybody's building their own executables, so when you check in GSC or Lua, those are pulled in from the linker, so everybody's going to see those changes. But when you check in a CPP file, that's built by Visual Studio, which not everybody's doing. So they're not going to see your new function. So let's say you added a new script GSC function and used it in a GSC file. You check that in, you link the fast file, or you don't check that in just yet. You modify both of those, you build the game from Visual Studio, you link the fast file, everything looks great. You check it in, you break everybody who doesn't build their own executables because they don't have that function yet. So when the game tries to link it, they get link errors, and at runtime they get script errors that don't even let them into the level. So that was a code data dependency. The way you need to get around that is by checking in your CPP file, waiting until build management or the experimental rat process has built the approved executable and checked it in, and then you can check in your GSC. So with script bundle assets, there is no code data dependency. you didn't have to modify any header files or code files to add collectible as an asset type because code isn't really aware of the asset type. You just put it in this .class file and then use it. It's fun and it's easy. The other type of assets we have are basically code assets. They break down into these two different categories that I should have invented, but I didn't yet. So basically, there are db.h files, CPP files, code the linker uses, code that the game uses that understands what these are. So you need to make a code change, get that built into executables that are checked in, and then you can use them in GSC or Lua, or wherever you want to use them, or even including them in a Zoner Z package file would be a code data dependency. So an example, okay, so I did break down code assets into two different categories. The first category is the moderate asset that is just defined by GDT. So for example, Shellshock is loaded. This is the entire, this is basically, I'm going to show you the code, but this is the main piece of code that's needed when, that the linker uses to figure out how to load in a Shellshock asset. So it's one line of code, including a static array that I'll show you how to write, and then it has one line to parse a custom field type. But generally, it's very simple. One line of code and a header change. There's also complex assets where you can write your own custom load function logic. An example of that is XCAM, because XCAMs internally are just JSON files that get pulled into various fields. The main rule is don't add a complex asset to the game. If you do, review it to Dan Olson. If you have a very good reason for needing custom load function, you can do that. But for the most part, these two types are going to be enough to add new types of data to the game.
Just a clarification,
Yeah.
this is for adding a new data type to the game.
Yes. Yes, I'm calling that new asset type. So when I say new asset type, I'm referring to the thing before the comma on the zone or Z package line. So image comma, shellshock comma, collectible comma, XCAM comma, and then the name of my asset. Is that a question? No? Okay. So we're going to get into this example. Actually, we're going to get into this example and then this example. We're not going to talk about these much, but you can look at XCAM as an example for custom load function asset. So adding a script bundle asset type is really just these 3 bullet points. You add your type.awi, you put the line greater than script bundle comma your type, you put that in the default.class file that's in share zone source. You add it in alphabetical order, or I will be very angry. Because it makes it much easier to find things. And then you can start using your new asset right away without waiting for executables. So this slide is, yeah.
Once you add this,
Yeah.
do you refer to this in the zone file?
Yes.
Or Z package file?
Yes.
As script bundle or
Yes.
the name
No.
that you provided as a default class?
Yeah, it's the name you provided. So it's your type. You would put your type, comma, your asset in the Zoner Z package.
Okay, so not script bundle.
Right. No, this is still right. I just haven't shown an example of. So the line that goes in default.class is greater than
Is this,
script bundle,
yeah.
comma, your type.
Right.
And then the
So-
line that would go in the Zoner Z package is your type,
Your
comma,
type,
your
comma,
asset
one.
name. Which I think I might do an example of. Will I? Nope.
No, good.
Okay, I won't. So really the trickiest part of adding a script bundle asset type is the AWI file. Have you guys not if you've added or modified an AWI? Okay, so the AWI is what Ape uses to decide what it should show you for field names and default values and groups and things like that. So this is a fairly simple example AWI. This is collectible.awi. It's the example script bundle asset I told you about. It has a few special fields up at the top that all script bundles need. They definitely need the second line. The other 2 are optional. So all script bundles need this line particularly, type comma collectible, and then don't show it and set value collectible. So this is just AWI scripting language. It's kind of nice because you can call add asset, and then this returns the asset you want, and you say dot show false, and then that returns the asset, and set value collectible. So you can set all these things inline and call functions on the new asset.
And creating this file also allows you to create a GDT of that type in a.
A GDT entry of that type in 8, yeah. Which you'll do for your assignment. It'll be exciting.
So this is for the base of this, we are using the script language we are using is AngelScript.
Is what? AngelScript? Sure.
So you can look up the reference online for that. We don't use the latest version of it. And
Okay.
then second thing is that there's like a script, there's like a huge wiki on all the functions, so you don't have to open, because many of these functions are kind of like, you don't know how to use because there's no like autocomplete or anything like that.
Right.
It's just a text file. So that script wiki will come in really, really handy.
Okay.
You know.
How can they search for that right now?
So just do AWI reference
Okay.
on wiki,
Okay.
and then that whole list will come in.
Nice.
I think it's like a good reference to have because you don't have any any
Yeah.
kind of like completion text, especially IntelliSense, anything like that.
Right. The reference I was going to recommend was you search for other examples in the dev files folder, but Sameek's suggestion is better, so do that. This is a bunch of different entries. The first 5 are strings, the next 4 are assets, and then it's a enum value and a string. I'll show you what it looks like in ape. Like I said, the first values are strings. The first 5 are strings, and then it's 2 models, 2 materials, or sorry, 2 images, even though they say material, and then an enum and audio. Oh no, that's just a string too. So you'll notice that the strings, it's just a box. You put in a string name. These are all localized strings because that's the way we do proper assets and localize them into the game. You could technically put any string data you want in there. It could be the name of another asset, but you don't want to include the other asset, for example. And then when you start to get to the things that are actually assets, this asset combo line with the second parameter over here, xmodel or image, basically gives you this nice blue arrow thing. So you can click this arrow, and it will take you to the model named P7MCCAI-AQU01. So that's just some nice stuff in Ape. And the asset combo image is even fancier because it has preview images. So you get cool stuff like that. I don't think I talked about this on the next slide. Okay, so this being an asset combo and this saying X model, that's what gets it to look nice in Ape, and what gets you these preview images, and these guys all autocomplete. It's very nice. It's better than what we used to have by a long shot. You'll also notice that I prepend xmodel underscore image underscore xstring underscore before each of these values, and that's the way the script bundle stuff works in the linker. So what the linker is going to do is it's going to go through all the fields that are defined for collectible, and it's going to look at the thing before the underscore and try to match that with a type that it knows about. So if you don't put anything, if you leave out the image underscore, then the linker is going to be like UI material. I have no idea what that is, and it's just going to ignore it. So here's the list of all of those prepended strings that you can use. Image, string image, blah blah blah, xmodel, xstring. This is a table in linker code that maps it to an internal type, so it knows how the linker knows how to build it. And then I'm not even sure we use the K2P fields anymore, but that's probably so that at runtime we know how to process it. So anyway, the thing I wanted to point out was the left column here. These are the things you can put before underscores in your script bundle assets. Bool underscore will make it work as a checkbox. Float, obviously you can set it to floating point value rather than int, which has to be a whole number. Image gives you an image. Streamed image is supposed to mark that image as streaming, but I'm not really sure that works because it kind of changed partway through T7 and maybe didn't get fixed. But yeah, just to point out again, the X string, X model image maps over to this thing before the underscore over here. So that's basically it for how to make a script bundle asset. It was 3 bullet points, and adding a code asset type is a lot more bullet points. But we will talk about it briefly because it's pretty cool and interesting, and you should at least understand how it works. Because this is the majority of what's in the linker. So the first step is still the same. You add your type.awi. It doesn't need those image underscore x model underscore things at the beginning of the asset names because you're going to have to define the behavior for each field. You have to create 3 new code files to follow conventions. The underscore db.h, the underscore loadobj.cpp, sorry, 2 new files, and then add the db.h file to this list, add your type and your underscore type in these 6 files. Mainly, what anybody does when they need to add a new asset type is they find another asset type, do Control-Shift-F, and then add theirs after that in every occurrence. But it's going to end up being these 6 files in this database.lst. And then again, like I said, this is a code data dependency you're introducing, so you have to wait for build management or rat to check in executables before you can use your new asset type that you've added this way.
Yeah, just look for the CL that build management checked it.
Yeah.
All that stuff.
Yeah.
Anybody who's-
But it's not guaranteed to work either, because maybe somebody like checked in a partial asset,
Yeah.
which I believe happened in T8.
Yeah.
So anybody push that slide on wiki gets extra bonus.
Yeah. Exactly.
The slide on the wiki? Oh no, we don't want people to know how to do it.
Exactly, no doubt you ask.
Yeah, just put the script bundle on the
Put
wiki.
script bundle, and then you put data asset, C script bundle.
Alright, so this is shell shock, which is fairly straightforward as far as code assets go. The main struct that defines what a shell shock parameters is down here. I highlighted the shell shock vision set part in yellow because that way we can just talk about one of the 8 sets of data it has. So yeah, this is a db.h file. It defines the structs for your asset, which are normal C code, and then it also defines this archive block, which gets used to generate the actual linker code that loads this asset in. So all these things are very important. If you leave out the archive part, Linker's not going to know how to build your asset type. For the most part, these 2 categories just match each other, mirror each other. For the structure that actually defines your new asset type, we also add asset mem asset type shell shock, which the linker uses to say, okay, I found an asset type shell shock asset. I'm going to use this shell shock parent struct and expect all of these fields. And then I'm also, when I come across a shell shock vision set, I'm going to use this struct and expect all these fields. So for the most part, we try to keep our archive block syntax the same as our code syntax. You'll notice the only exception here is that this says X string and this says const char star. This could actually have said X string to make it exactly match and be pretty, but you can't just put const char star here because the linker knows what this is, doesn't know what this is. So, oh yeah, and then just real briefly, this is the actual code definition of shell shock vision set. I just copy pasted a bunch of this stuff and couldn't fit it all in the same vertical layout. Anything else I want to talk about here? Oh, question.
So those archive blocks, those aren't being like stripped out and compiled, they're being parsed by the linker?
Yes.
Which is running through all of the header files.
Yeah, technically they're parsed by a Python script that has the word archive in it. That used to be a code file, but is now Python.
Oh, wait, so we don't have this auto-generated code files?
Yeah,
No,
we
do.
do,
Oh, good.
but it's a Python script that generates them.
Oh, okay.
Yeah. So there is a text Python parser which basically goes through all the archive blocks
Yeah,
and then uses that to generate the code files.
yeah.
And what is the load and the save files that are auto-generated also?
Those are auto-generated from the Python script that
Using-
parses the.
Okay, so those use, by including the thing in the load and the save on the previous page, and also creating these archive blocks, those
Yeah.
things together work to create those auto-generated CPP files.
Partly. So it's also, I believe, a CPP file called yourtype_load.cpp and save.cpp
Right.
are going to be generated. But the files you actually have to modify were just these two. You have to like include your file in it. So there's also these two files that you touch manually, and then the load and save files that are generated. Just as a side note too, those generated fast files, those generated code files, we don't check them in. We just let them generate on everybody's machine under database/generated.
And if you want to look at them, or you want to look at them if you want eyeballs to tweak.
Which one's the file that needs to
Sarah.
be included for your stuff to be recognized by other, or included by other assets? Is that in this list, or that's separate?
For your probably it's probably the archive block in the db.h is probably the answer to your question, if I'm understanding your question right, which your face looks like I'm not understanding your question right.
Well, there's certain ways you can just like have an asset type and it can be, you know, you can put something into the zone file, and there's another one where you to include it like as a sub asset inside another asset, you have to do something different.
So to include it in a zone file, it's I think asset names.cpp.
Yeah.
To include it in another asset type, that other asset type would have to include your type db.h that has the archive blocks and the struct definitions. So again, this is all of the shell shock fields. We can just focus on the stuff inside the yellow box. Like we saw before, this is my last slide by the way. We saw that the shell shock vision set has 3 fields. It has a name, an in time, and an out time, and that the entire struct is called vision set. So if you were to access these fields in code, you would say vision set.name, vision set.intime, vision set.outtime. And then on this next slide, we see we've used these 3 fields: vision set.name, .intime, .outtime.
See, this is what I was talking about actually, like on the last thing, the
Asset load handler GDP.
the CSP_bool, that name.
CSP_bool.
Like the last, like,
Alright, this guy.
yeah, so you have to define, if you want to use like your own asset type as something that can be included in this kind of format, right? You have to create your own. Define for that.
Oh, you mean the part specific
Yeah.
fields?
Yeah.
Oh, yeah. I think we talked about it earlier. But like big, yeah.
Yeah, there's this part specific field function that you could, if you only wanted to use it in one asset type, you could use part specific field. You can look at shell shock params again for an example of that. But if you wanted to use it everywhere, you would have to add to this CSPFT array.
Okay, sure.
If you wanted life to be easier. So yeah, like I said, vision set.name, vision set.intime, vision set.outtime, and then these strings are the strings that correspond to the AWI. So there was a vision set name field in the AWI. The linker reads that, puts it into the vision set.name field here, and parses it as a string. So this is kind of the code. This CSPFT_string here is code's version of X string underscore in the asset name that the script bundle asset would have used. This SSF macro here is basically offset of. So it looks at the shell shock params struct and figures out what the byte offset of vision set.name from the original shell shock params is. So this is something like you cast null to the shell shock params pointer type, and then dereference it, dereference the name field, and then get the pointer to that. So it's an offset from where the actual struct is, but it's implemented as an offset from null. You don't need to understand any of that. You can look, if you're curious, you can look at the definition of SSF later, and maybe it'll make more sense if you give yourself more time for it. But yeah, that's all I have for my linker presentation. I'll talk a little bit about your assignment on the next slide, but I was not doing the assignment. We'll probably not be interested in that, so. Yeah, any questions? Oh, Chris was first.
Could you talk a little bit about the Delta fast file?
Sure.
Or is that beyond the scope of?
No, I'll talk briefly about it, just as a concept of what it does. So back on Black Ops 2, we shipped all of our fast files, and then we made underscore patch fast files that were a part of every patch. Yeah, so if we wanted to change an asset in Core Common, for example, we'd have to pay for it again in Core Patch, basically duplicate all the data for it, and link that whole fast file and put it in the patch. What we do now is pretty much every common fast file is Delta patched. So we download the shipped version of the fast file, do a binary diff of it against what you've built locally, and then save out that binary diff and load that binary diff at runtime. So that means we can delete assets, which we could never do before, because the best we could do was overwrite it with a smaller version of the asset, but we still had to pay for the memory because it was part of Core Common, and we couldn't modify Core Common in a patch. But now we just have the Core Common Delta patch, so we can delete, move, rename, resize, do anything we want. It's just a binary diff applied at runtime, and it's very powerful and does nice things. Yeah.
How and what technologies are like my changes and fast file today based on? Are these similar?
Yes, they are fast files. My changes is a fast file that it's a fast file and an executable. So my changes.exe runs, and it looks at your P4 change lists and creates a list of all of the assets that you're modifying. Then it outputs that to mychanges.zone, or I think it outputs it to a Z package that's included by mychanges.zone. Or no, it does output it to mychanges.zone. I'm gonna stick with that. And then you link mychanges.ff from that .zone that got generated, and at runtime that will override any other versions of the assets that are in mychanges.ff. Fast file of the day is actually pretty much the same thing, except that's what we do in the live environment. That fast file is not auto-generated because everybody downloads that fast file every time it changes. When they press X to go past the initial start screen, and they see like downloading update 0%, 5%, 10%. So every image, every string we put in that is taxing our servers and annoying our customers. So we have to make sure that everything we put in that is very important, and we also have to make sure that nothing we put in there breaks anything, because we can work on a fast file of the day today, push it out to the public tomorrow, not give it the week and a half of testing that our patches usually get, and cause a lot of problems for everybody, which we can then fix the next day. Yeah.
So do all like the my changes executable, whether it's run through like script develop or through Rex, it all does the same thing.
I'm not sure. Does the one that's script develop do the same thing, or does it generate its own list?
Yeah, it's pretty much the only difference I think in the script develop is that if you happen to, and this is a bug, but if you happen to build it using script develop, it only builds it using a dev link, P4 linker.
Oh, okay.
So if you want to use your dev linker, which if these guys make a change to the linker,
Yeah.
then you cannot use the script develop one.
Okay.
But that's a minor thing.
Yeah.
Otherwise, it does pretty much the same thing. Like it looks at the solution or the zone file that you're modifying. Because script develop has the concept of like which map you're working on or whatever. So it looks at that, and then it looks at the files that you're loading, and then makes the then builds all that.
Okay, so it is slightly different because it's gonna look at the zone file you're loading instead
I
of
think
just
it
all of
looks
the
at the
assets
zone.
you
Because how would it
modified.
know otherwise, right?
Okay.
Well, it may also look at your P4 changes.
It also looks at your before changes. Yeah.
But the UI editor live update uses the my changes file too. So what it does is basically like it takes whatever you have currently, it puts it in my changes underscore include.csv, and then or
Z package.
or Z package or whatever. Yeah, I mean I'll engage that next time, but yeah, that's how that's supposed to look.
No, it does put it in the Z package, otherwise it wouldn't work.
Yeah.
What's up?
So, in a previous life, I had to write a thing that went and scraped through a crap load of files, sitting on disk, and opened them up and read some header information from the next one. Aside from being loose file operation, we discovered that the performance on it was severely impacted by the virus scanner jumping in and stopping the process that we were running every time we wanted to open a file. Has that been something that we've encountered with our linker process, and how do we get around it?
The way we get around it is IT has set up a rule that ignores all assets under the game folder. So yeah.
So don't put your
Don't put your viruses
don't pull
under
things down
T.
into a
We'll try it.
I'll be sure to move those.
Put your viruses.
Not actually happened.
C7 something good.
That happened, we have a email on the tone. That's a directory. It's going.
Yeah, we tried that also, but ours didn't work.
Yep.
Quick one, I want to mention that the script bundle does support more assets like AI types and stuff like that. And one of the things that Crow mentioned that we have that kind of prefix that we look for. And we would like to change that ideally.
Yeah.
Because the prefix is kind of like very, it's not a great way to identify the asset. But more important thing is that for the script bundle can be considered as one of the ways to add a composite asset type that you want, for your game mode or whatever you're working on, without having to worry about changes to code or anything like that. So it really empowers our script or design team, especially our technical design team, to create assets that are composites of just values, parameters, settings that they want to load, and they can just make it by changing the AWI. That's where a bit of technicality comes in, and then they can load it into the game and just start working on it. Point there is that it basically allows our game to be more data driven and go through the generic asset loading process without having to change any code. And that's kind of the biggest advantage of it. So,
But that only works for stuff that's you're trying to access from script files and like Lua, right?
no, you can add
Access from the game.
Yeah, the script bundle is accessible in code as well. So we use that for a lot of code. When it comes to code, then you have to be an engineer to be able to access it. But and one of the things is that once you make these script bundles, you can access them in Lua. You can access them Lua. I'm not sure. I haven't done much, but you can access them in script, both on server and client, or independently. You can define it that way. The only cost that you're paying for those is that you are paying once you get that asset and pull that asset in the script. You're paying for script variables, and then there is a little bit of special handling for that. But that's something that we encourage our designers to use a lot, as compared to just putting some script files which just say like, hey, this is how my asset looks like.
James actually put in a call system.
Yeah. Once
So
you
good.
call them, yeah.
I wasn't sure about that. Yeah.
So he said it didn't end up saving any variables because everybody just grabs stuff and holds on to it anyway.
Right. But unless you use that asset, you're not paying for the variable cost, which you shouldn't worry about because Trevor is going to bump up the cost again. But yeah, something to remember that's powerful tool to have.
So GSC and CSC don't push anymore?
No.
All that? Okay.
You just have to pull it, and then it will runtime allocate that many
Okay.
variables.
Great.
And if you delete it,
That's the same as Lua now, so they're all pretty consistent with each other. Yeah. And if you want, you can do the intern assignment and learn how to implement one in Lua.
I think I'm going now.
Any other
I guess
questions?
it's just a game now.
Okay. Alright, well thanks.
Thanks, man.
Everyone for coming, yeah.
Yeah, no.
Sure, it'll be fun.
What did you say? Anybody want to do this?
What do they want to do?
Did you say with your mouth?
Oh, it'll be fun.
The most dry presentation. But thanks, Steve, you did a good job. Thanks, Steve.
Yeah, no problem.
I mean, I kind of wish you had this weeks ago, actually, as we're like linking things just like.
early on.
Yeah. But then again, weeks ago we might have.
Would,
just
how much
super
would
lost.
you, yeah.
That one, oh.
How do I turn off the plugin? Is I control shift F10 or something? No.
Back when I was
There's some key combination.
To do what?
To what?
To turn off the presentation.